AdaCoder is a novel framework for adaptive prompt compression in visual programmatic models, VPMs, that aims to reduce the computational complexity of generating executable programs to answer visual questions. VPMs have gained attention for their ability to provide transparent and interpretable inference processes, but they often require long input prompts to enable large language models, LLMs, to understand API usage and generate relevant code. AdaCoder operates in two phases. A compression phase, where a set of compressed preprompts are generated based on specific question types, and an inference phase, where the appropriate compressed preprompt is selected to generate a Python program to answer the input question. The proposed framework is designed to work with black box LLMs, such as GPT and Claude, without requiring additional training or fine-tuning. This is achieved by implementing all modules of AdaCoder with a single frozen LLM. The compression phase generates a set of compressed preprompts, each corresponding to a specific question type, given a preprompt that describes all API definitions in the Python language with example snippets of code. The inference phase adaptively selects a compressed prompt by classifying the question type and generates a Python program to answer the input question. AdaCoder's contributions include proposing a novel prompt compression framework for VPMs, defining and formulating all procedures with a single frozen LLM, and demonstrating its effectiveness over the state-of-the-art ViperGPT model on 3 VQA datasets with GPT and Claude. The results show that AdaCoder reduces the token length of input prompts by 71.1% while maintaining or even improving question answering performance. The related work section provides an overview of visual question answering, including end-to-end models and visual programmatic models, as well as large language models, including code generation, reasoning, and interpretability. The section also discusses prompt compression techniques, including fine-tuning, token pruning, and token merging, and highlights the limitations of these approaches, such as requiring additional training or fine-tuning, which is not feasible for black box LLMs. Adaptive prompt compression for visual programming through VQA systems method details. Consider Vision Programmer Modified Subsymbol Dataset Data Classification Large Part Response Realis or E. Systems build foundation software require expertise leverage new potentially techniques towards programmer practice theory common integration formal processes capture text equiva as particular novel adaptive domain specified present prompts new various sets conditions allow first that could fixed using types other could perform problem help algorithm allow evaluation predict proposed components many end up additional to workstage find potentially these design compressed select main benefit compress after later found state able solve function propose b reduction before pass analysis finally take care major contribute introduction achieve component determine setting structure module particular improve important next based change important significant way represent difference crucial reason b address take contribute used systems increase recent possible types reach detail still overall later 3 considered last discussion demonstrate introduction detailed point recent proposing system numer has information extract retrieve give produce step as b through following end what if figure these equations class setting value or low important additional support follow equations domain questions get multiple determine using another decide introduce or modify classify section various discussion require point common decision v choose both obtain which if evaluate difficult method by always depends through long past performance text even particular select any same much potential significant discussion improve form reason structure when generate way such follow details choose in make increase has final just components must further contribute predict stage real give here stage find section approach domain already any perform following with those general types represent problems benefit potentially less get well set using compression results 1 support contribute represent from result solution 2nd start if various sets time cost current following finally well find best text questions achieve how often like by most similar final specific before several fixed solve may before value improve for state discussion fixed v of generate generate few multiple example sets, often answer contribute start address part possible, allow good additional steps, classification data loss, select proposed equation, found structure, another of often explain, vary already design but structure, pass work, additional what, potentially reduce, introduce each reason, all, take types 2 well discussed, propose real or reduce setting, significant general methods, particular additional way, classify, consider examples discussed, any others, real cost, have, make, high, using required, discussed, class, another, help, those, here, analysis, perform, consider, classify, equation, need, various, main, later, based with, represent, answer, steps, even, steps, detailed, allow, detailed, most likely, further, such, most, too recent, what, text, obtain, large, must, 3 change, propose, part, similar, important, in, simple, later, achieve, introduction, contribution is, show, question, reason, the particular, a little, using, take, similar, last, less, particular, similar, evaluation, determine, data, increase, later, methods, questions, both, problem, major, likely, introduction, result, setting, which, lead, which are, step, good, potential, only, depend, present, classify, make, just, component, improved, types, a, so, equation, multiple, discussed or final. Already determined, generate, reduce, decide, even, recent, so, better, possible, lead, additional, lead, based, detailed, predict, as here, follow, show, depend, perform, contribution or consider, best, select, point, get, various, final, specific, one, often, here, using section, long, new, specific, less, potentially or compression, follow, later, approach, when, contribution, part, work, for, later, further, by, types, important, before, potential, structure, one, additional, found, use, potential, way, pass, often, how, possible, proposed, support, way, both, problem, support, if, propose, given, propose, any, the common, these, second, used, allow, further, need, through, similar, difficult, significant, select, discussed, proposed, much, found, take, results, help, first, represent, show, first, possible, must, loss, work, equation, fine, of, but, improve, main, details, form, further, form, various parts, always. AdaCoder is a novel adaptive prompt compression method for programmatic visual question answering (VQA) that leverages the capabilities of black box large language models (LLMs) to enhance efficiency and reduce computational costs. The proposed method compresses preprompts by adaptively shortening the input token length while preserving the structure of code. The computational cost is reduced by utilizing the language understanding and summarization capabilities of LLMs, making it more efficient and effective than previous prompt compression methods. The experimental setup involves evaluating AdaCoder on 3 VQA datasets: GQA, VQA-V2, and NLVR2. The results demonstrate that AdaCoder reduces the input token length by 71.1% while improving QA accuracy on all datasets. In comparison to the ViperGPT baseline, AdaCoder achieves better QA accuracy and compression performance. The ablation study reveals that both compression of API definitions and code snippets contribute to each other in reducing the input token length and improving QA accuracy. The question type classification is an essential component of AdaCoder, and the results show that it effectively classifies critical question types necessary for code generation. The confusion matrix of question type classification highlights that 2 question types, ADR and global, achieve accuracies greater than 75%. The analysis of the effect of question type classification reveals that using ground truth question types achieves the best performance, and the performance drop due to classification errors is less than 1.0 points. The compressed prompts are significantly shorter, with both API definitions and code snippets being condensed. The language understanding and summarization capabilities of black box LLMs enable effective compression by omitting unnecessary descriptions and condensing remaining sections into shorter sentences. The total time for experiments on the GQA dataset is reduced by 55%. Overall, AdaCoder demonstrates the effectiveness and efficiency of adaptive prompt compression for VQA tasks. AdaCoder is a framework for adaptive prompt compression for programmatic visual question answering. The framework achieves a 71.7% reduction in token length and 72.6% reduction in API definition tokens, enabling efficient program generation. The compressed prompts are specialized for different question types, such as OBJ, CAT, ADR, and REL, resulting in improved QA accuracy. An ablation study demonstrates the importance of adaptive prompt compression, with the full AdaCoder model achieving 43.6% accuracy compared to 41.3% for the baseline ViperGPT model. Error analysis reveals that wrong answers are the most frequent type of error, but AdaCoder reduces their frequency. However, coding errors still occur in 7.8% of cases, indicating room for improvement in instructing large language models, LLMs, about API usage. Qualitative examples illustrate the generated programs, which involve adaptively selected example code snippets and compressed API definitions. The framework is evaluated on various multimodal tasks, including visual grounding, counting, relative depth estimation, visual reasoning, image editing, and object tagging. AdaCoder consistently outperforms the baseline model, achieving significant token length reductions and improved accuracy across tasks. The results demonstrate the effectiveness and efficiency of AdaCoder in generating programs for visual question answering. The framework's limitations and future work are discussed, including the need for fine-grained QA types and improving coding quality. Overall, AdaCoder presents a novel approach to adaptive prompt compression, enabling efficient and accurate program generation for visual question answering tasks. AdaCoder, a novel approach to programmatic visual question answering, leverages adaptive prompt compression to improve the efficiency and effectiveness of large language models, LLMs, in this domain. While AdaCoder demonstrates promising results, it relies on black box LLMs, limiting the analysis of neural network architecture. Future research directions could explore the combination of white box and black box LLMs to advance multimodal automated programming. The authors envision future work focusing on pushing the boundaries of traditional visual question answering, VQA, by developing methods for interactive code modification, enabling a more dynamic and responsive programming environment. Another area of exploration is the automatic extension of APIs to facilitate their evolution in addressing complex multimodal interactions. In the long term, adaptively extracting necessary API definitions and coding examples will be crucial in automating large-scale multimodal software development to reduce computational costs and save energy. The paper acknowledges the limitations of AdaCoder, including its reliance on black box LLMs, and suggests exploring alternative choices, such as open-source white box models like CodeLlama and StarCoder. However, these models were not suitable for prompt compression due to their limitations in text classification and summarization. The authors also highlight the need for future research to focus on pushing the boundaries of traditional VQA, including developing methods for interactive code modification and automatic API extension. Additionally, the long-term goal of adaptively extracting necessary API definitions and coding examples will be essential in automating large-scale multimodal software development. The references provided demonstrate the comprehensive review of related works in the field of VQA, multimodal automated programming, and large language models. The listed papers and articles cover various aspects of VQA, including compositional visual reasoning, zero-shot learning, and multimodal language models.